and these are the specifications. You need to know what is an electric charge, what are insulators and conductors, and how do we investigate that the insulators can be charged by rubbing. Rubbing means friction, and positive and negative charges, how they are produced in a material. Okay, the transfer of electron causes thing to become negatively charged, and loss of electron causes things to become positively charged. The forces, type of forces between the two charged bodies, and electrostatic phenomena in terms of movement of electron, potential dangers of this electrostatic charges, we have to discuss, and then the uses of static electricity. One more topic which is not discussed in this video, and this was taught in your class O2, that is charging any conductor by induction. So that will be discussed in the other video. Okay, so let us start. Electrical conductor and insulators. Any conductor is a material which through which electric current can flow. Metals are good conductors, you all know it. Electrical insulators have a very high resistance to the flow of electric current. But there is one thing, conductors cannot be charged by rubbing, and insulators can be charged by rubbing. So here is a list. Copper, this is already filled in. Conductor, rubber, steel, mercury, plastic, wood, diamond, and graphite. So these are to be filled in: rubber, insulator, steel, conductor. You did this all in your junior classes 4, 5. Okay, so these are the things like regarding conductors and insulators. What is an electric charge? It can be either positive or negative, and any atom has electrons, protons, and neutrons. You know it. And electrons have negative charge, and proton has positive charge, and magnitude of charge on electron and proton is same. Okay, neutrons have no charge. So electrically, an atom is neutral because it has same number of electrons and protons. So atom is neutral. But when electron is gained or electron is lost, that will cause atom to become either positive or negative. So if electron is lost, atom will become positively charged because there will be less number of electrons compared to number of protons. Okay, and an electron is gained, there will be more electrons, so atom will become negatively charged. Static and current electricity, the major difference: static electricity, that remains stands still in the object. Okay, the charges remain stationary on the object. When you rub any insulator, charges remain there on the surface. Okay, so insulators will hold the charge for longer time. Current can flow through the conductors, which cannot flow in insulators. So how do we charge material using friction? Okay, we have to rub it against another insulator. Okay, rubbing conductor with a cloth. Cloth is an insulator, and copper rod is a conductor. So when you rub copper rod with cloth, it won't be charged. Actually, the electrons will be transferred, but this copper rod will take electrons from the surroundings, or if it gains electron from the cloth, it will lose it to the surroundings, so it won't remain charged. But insulator, when it is rubbed with another insulator, transfer of electrons takes place, and through both insulators they gain charge. Okay, material there that gain electron becomes negatively charged, and that loses electrons becomes positively charged. Here is a diagram, and there is a rod shown, and this may be made up of perspex, which is rubbed with the cloth. So it means there are positive signs here shown. It means these atoms have lost their electrons. So these electrons have been transferred to cloth. So cloth has become negatively charged on gaining those electrons. Now charged bodies, they have some kind of force between them. Okay, and we call it electrostatic force. So what type of force? When the charges are similar, the force is repulsive, and the charges are opposite, the force is attractive. Here the first figure shows this is the water, this is stream of water which is running, and charged comb. So the water is bent towards the comb. It means charged bodies, they attract each other. Here balloon, rubbed balloon, it is attracted towards the wall. So different charges attract and similar charges repel. Okay, so it means the law of charges, like charges repel and unlike charges attract. Here there is a boy who has his hair stood and away from each other. It means the hairs of this boy are charged, so they repel each other and they become erect, move away from each other. So the boy must have stood on some charging machine. Okay, he might have kept his hand on some charging machine, and that kind of machine is called Van de Graaff generator. Here there is a diagram again which shows attraction and repulsion. Two positively charged rods, when they are brought close to each other, so the one which is hanging means free to move, so it will move away from this. In the same way, two negatively charged rods also will repel each other. But unlike charges, positive and negative, they will attract each other. Here some blanks to be filled in with these appropriate words. Static electricity occurs when electric dash remains on an object. Let's see what comes out of these. You might be able to solve before I tell. Charge remains stationary. An insulating object can be charged by rubbing it with another insulator. One of them gains what? Electrons and becomes negatively charged. The other becomes equally what? Positively charged. The law of charges states that like charges repel and unlike charges attract. Now, hazards of static electricity. It can be dangerous. Okay, when huge amount of charge develops in any body, that may be dangerous. And these are some examples are lightning conductor, which was taught in the class in your O2 when you were in O2. So there is another example. See this one, this explosion. Bunsey Field oil depot explosion opposite in December 2005. That was also because of the spark. It means there must be some any nozzle or something which might have been charged, and the charge must have been very large amount of charge. Okay, so that is why that's and the two opposite charges, they tend to attract each other. So when the charges they jump towards each other, this type of explosion may take place. Fuel pipe problems, and this happens especially when refueling of aeroplane is done. Okay, so our petrol in car, like vehicles are there at the station, pumping station to get the petrol. So that can also again happen, not only for the aeroplane. It may be a problem when you get your vehicle to the pump, and the pump nozzle may be charged. The pipe might have charge in it due to the friction. Okay, when oil comes out of the nozzle, so the friction between the nozzle and this oil will cause these two to become charged, and that explosion again can occur. Okay, if a charged car's body or truck's body or aeroplane's body has opposite charge to that of the fuel droplets, then the charge jumps. So it may cause spark. Anti-static flows. These examples, like anti-static flow, we did not discuss in our O2 class. Let us see it here in operation theater. What happens? It is important that the doctors do not become statically charged when walking around. Okay, it means floor should not be charged, or those doctors should have some kind of shoes which cannot be charged due to the rubbing with the floor, or floors might be coated with the anti-static material. Okay, so these are the dangers in the hospitals also. So anti-static material is to be used so that the doctor's body does not get charged due to rubbing. Uses of static electricity. Now we will talk about the uses. Spray painting. So it means the paint particles are to be charged. So like charges repel each other, just like the scene you saw in the previous figure. The boy had his hairs, they were away from each other due to the like charge. So in the same way, paint particles are given charged. Okay, so if they all are given positive charge, means they will repel each other and they will move away from each other. So they will spread out and they will cover large area. So the charge may be given by electrostatic generator if a bigger body has to be painted. Okay, so the paint droplets leave, they repel each other and spread out to form a fine cloud of paint. So metal panel which is to be painted is connected to the negative terminal, so that the positively charged paint particles are attracted towards that negatively charged body which is to be painted. Okay, so the painting is done in shorter time and less paint is wasted. This is the major importance of this method of using spray painting. Inkjet printer, which is also mentioned in the syllabus breakup, which was shared with you earlier. So here inkjet printer, the ink droplets, when they come out of this nozzle, they become charged, and these are the deflection plates. If there is a positive charge on the droplets, so they will be attracted towards the negative plate and they will strike the paper, upper part of the paper. Okay, so the plate deflection plates charge has to be changed quickly depending on the requirement, whether the writing has to come on the top or writing has to come at the bottom of the paper, or there should be no writing also, that also should be taken care of. Okay, so spots of ink are given an electric charge as they leave the ink nozzle. Okay, the deflecting plates cause the drops to hit the right part of the paper. And the charge on the deflecting plates change many times per second so that each drop hits the paper in a different position. So this is one type of inkjet printer. There is another diagram here. These are charging electrodes which will cause the droplets to be charged. Okay, and they are to be controlled by some computer instructions. Okay, whether the print head is moving over the writing part or blank part. If it moves over the blank part, means the droplets should not be charged. So it means deflection charging plates will be off and this will go straight. Okay, and in the same way, when the charging electrodes are on, means the droplets will be charged and they will not fall on the paper. This will happen when the blank part is to be done. For the writing part, there should be what? The charging electrodes will be on or off. This is to be decided depending on what type of thing is to be carried out. Okay, deflection plates, of course, deflection plates will be charged. So if the charged droplets will reach this region, if they have charge on them, they will be deflected towards that plate. Suppose there is a negative positive charge on the droplets and the lower plate is negative, they will deflect towards it and they will fall on it. Means the charged droplets will be there when the print head passes over the region where there is no writing. No writing means ink should not reach the paper. Okay, so the charging electrodes will cause it to be charged, and depending on what type of deflection plates are there, if the lower plate is negative, means the droplets will be positively charged, they will be attracted towards it and they will fall in this gutter. Okay, means they won't reach the paper, means print head is moving over the blank area. If the print head is moving over the right like area where there is some writing, means the writing should be there on the paper. It means the ink droplet should go straight towards the paper. Means they should not, charging plates will be off, there will be no charge, so that means ink droplets will go straight. So this is another way of understanding inkjet printer. It means these plates, they depend on the instructions from the computer. Photocopier, and the major part of this photocopier is a photoconducting drum. It's made up of selenium. Okay, and what is photoconducting material? When it is exposed to light, it will become a conductor. Otherwise it will behave like insulator. Insulator means when we spray some charge on it, that charge will remain there on the body of this conductor. So here conductor is shown to have positive charge all over it. Okay, and it will hold that charge till it is exposed to light, so charge will not go away from it. Okay, so there is some material which is producing charge, we call it charging wire here, which is producing positive charge on this. Now the document which is to be photocopied, when it is placed here on the glass window at the top of the photocopier, suppose this is a document, it's a plus sign shown here, so this is bright area and around it is a dark area. You know that the bright color, white color will reflect light and black color will absorb light. It means this is a light source bulb. Light from the bulb hits the paper and it reflects off the bright area. Okay, white area will reflect the light. This light will pass through the lens and will fall on the drum. So on receiving the light, what will happen? Which part? Of course, this part will be receiving the light and it will lose its charge because it will become conductor. Charge will flow inside. Okay, so the positive charge will go from this region. The rest of the region has positive charge on it because it did not receive light from this. The black toner now, it sticks onto the drum. Black toner must be charged, oppositely charged. So this toner will sprinkle that ink on the paper. So where will ink stick? Where there is a positive charge. It means negatively charged toner will spray this ink onto the drum and ink will stick on those areas which have charge on it. Okay, because they won't be attracted towards this region. They will be attracted towards the charged region. Now this paper will be like print of the paper will come on this other paper, and that paper will have the copy of the paper which was to be printed, and this is to be pressed so that the ink sticks permanently. So there is a complete diagram shown here on this page. Light, document to be photocopied, lens. This is the same drum which has charge coated on it. The region where light strikes, that will lose the charge, and the region where light does not reach, like black areas, so that will retain its charge. And after the toner sprinkles the ink on it, ink will stick on the black areas, and that means that writing part will appear here, and ink will not stick on those areas which have lost their charge. Now this paper enters from this side, this is a white paper, and the drum rotates. When this drum rotates, whatever is there on this drum in the form of that black ink, that comes on the paper, and this paper here passes through these rollers here, these heated rollers. They will make that ink permanent on the paper. Now this is your photocopied paper which comes as output. Smoke precipitator. This is to remove the smoke and dust from the chimneys of the industries and factories. So you can see these are two metal plates, and in between there is a grid of charged wires. Okay, and this ash or waste gases, they will rise up because they are lighter. So when they rise up, they will pass through this grid. Okay, and they will gain the charge. Okay, charge on this wire grid and the metal plates will be opposite. Okay, if the Wire grid has positive charge means metal should have negative charge on it. When these dust particles they pass through the grid, they will acquire that same charge as that of the grid. Okay, because when they will pass through this grid, they will lose their electrons towards the grid, and they will also become positively charged, and they will be attracted towards the metal plates on both the sides. Okay, is used to prevent dust and ash produced by coal-fired power station from entering the atmosphere. Okay, so atmosphere remains pollution free. Okay, the ash and dust becomes charged as it passes through the charged grid of wires. The ash and dust is then attracted to the oppositely charged metal plates. And when the plates are shaken, they may be washed. The accumulated ash, which is accumulated on these two plates, and dust, it falls and it is to be collected and removed safely. So this is another use of static electricity. Now there are some questions to be solved. These questions you can see and you will answer in the Google Classroom. Okay, and this will be like, these are very short questions and they are very easy. You can solve them very quickly. Okay, and in the other video you will get about the current electricity and charging by induction also, how conductors are charged by induction. You studied it already in O2. That will be a quick review of all that. So you watch that video and then we will solve some questions related to. So there are altogether 4 questions. Okay, causes, problems and all that. You do it. Okay, so we will see in the next video, and Allah Hafiz.